Chapter 4, Congruent Triangles by Robbie Leslie
and Andrew Tsangas. First up, we have classifying triangles by their sides. First, we have an equilateral triangle with 3 congruent sides. Next, we have an isosceles triangle with 2 congruent sides. Lastly, we have a scalene triangle with no congruent sides. Moving on.
Next, we have classifying triangles by their angles. An acute triangle is a triangle with 3 acute angles. An obtuse triangle is a triangle with 1 obtuse angle. A right triangle has only 1 right angle, because it only needs 1, really. And then next we've got an equiangular triangle with 3 congruent acute angles.
Moving on. Now let's try some practice problems. Number 1, classify this triangle by its sides. Robbie, is that scalene? That is correct.
Andrew, number 2, please.
Is that an equilateral triangle?
Why, yes it is.
Number 3, who in the class would like to answer this question? Eeny, meeny, miny, Robbie.
Yes, is that by any chance an isosceles triangle?
That is correct. Let's classify these next 4 triangles by their angles. Number 4, Robbie.
Is that a right triangle?
That is correct.
Andrew, number 5, please.
Could that be an acute triangle?
Yes!
Number 6, Robbie.
Is number 6 by any chance an obtuse triangle?
In terms of that, it is correct.
And now, Andrew, could you please do number 7 for the rest of the class?
Well, if you look at number 7, there are 3 congruent angles, therefore making the triangle equiangular.
Correct! And now, moving on.
Next, we have SAS and SSS. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the triangles are in fact congruent.
And next we have SSS, which is if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are indeed congruent. Moving on. ASA and AAS. ASA, if 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the triangles are indeed congruent.
AAS, if 2 angles and the non-included side of one triangle are congruent to the corresponding 2 angles and non-included side of a second triangle, then the triangles are indeed congruent.
That's an interesting topic, actually, we got there.
Next, we have probably the most important topic,
Coordinate proofs.
They're very interesting. Coordinate proofs use figures in the coordinate plane and algebra to prove geometric concepts.
Now we're gonna figure out how to place triangles on a coordinate plane. Step 1, use the origin as a vertex or center of the triangle. Step 2, place at least one side of a triangle on an axis. Step 3, keep the triangle within the first quadrant if possible. Step 4, use coordinates that make computations as simple as possible. And for going back to step 3, the reason that you want to do that is because it keeps all the numbers positive. Moving on.
Now, we're going to show you how to do a coordinate proof. Number 19. The segments joining the base vertices to the midpoints of the legs of an isosceles triangle are congruent.
And the given for this one is going to be that isosceles triangle ABC with AC congruent to BC, R and S are midpoints of legs AC and BC. And also, you're going to want to prove that AS is congruent to BR.
For this coordinate proof, we are going to use the distance formula. AS equals the square root of 9a squared plus b squared. BR equals the square root of 9a squared plus b squared as well, since AS is equal to BR. Then, using the reflexive property, segment AS is congruent to segment BR.
Moving on now. Congruence transformations, really interesting. Riveting stuff, really. Reflection is a transformation over a line of reflection, and each point of the pre-image and its image are the same distance from the line of reflection.
Translation. A transformation that moves all points of the original figure the same distance in the same direction.
Moving on.
Now we're going to do some practice problems. Robbie, can you tell me what type of congruence transformation is number 1?
Is that by any chance a translation?
That is correct.
Andrew, number 2, please.
Is number 2 a translation as well?
No, number 2 is actually a reflection.
Moving on. Now for our reflection. First, we covered classifying triangles by their sides.
Second, we covered classifying triangles by their angles.
Next, we had SAS and SSS.
And fourth, we had ASA and AAS.
Fifth, we had probably the most important coordinate proofs.
And next, we had congruence transformations.
The end. Thank you for listening to our wonderful presentation. We hope it helped you understand Chapter 4 triangles. We wish you good luck on your midterm exam.
We are not held liable for any incorrect problems you have in this chapter. Thank you and goodbye. Have a wonderful rest of your day. Adios.